To understand how Fat Man works, we first need to understand the parts of the nuclear weapon. Starting from the back, we have the California parachute tail, which was meant to stabilize the weapon when dropped from an altitude of 9,000 meters. Next, we have the barrel tube collector, which helps measure the altitude of the bomb. This section contains the barrel tube switches, radar, and timers. Moving further ahead are the 32 detonator wires connected to the firing set, also known as the X unit, placed near the charge. On the opposite end of the weapon are 24-volt batteries required to detonate the weapon. Moving to the exterior are 3 arming plugs that are removed before the bomb is dropped. These are the 4 Archie radar antennae that activate when the bomb reaches its detonation altitude. Finally, at the front of the bomb, we have 4 AN self-destruct fuses. These devices were made to self-destruct the weapon if the bomb failed to detonate after being dropped, ensuring that the weapon wouldn't fall into the hands of the enemy. Located at the heart of the weapon is the internal neutron generator. This component is responsible for emitting neutrons essential for the nuclear chain reaction. Inside is a beryllium pellet and a beryllium shell, with inward pointing spikes encased in polonium, a radioactive substance that emits alpha particles. The entire neutron generator assembly is 2 centimeters in diameter. Surrounding the neutron generator is the main fission material, a highly radioactive 6 kilogram plutonium sphere measuring around 9 centimeters in diameter, encased within another concentric sphere of highly radioactive uranium-238. This deadly combination acts as a neutron reflector, increasing fission efficiency required for detonation. Surrounding the uranium sphere lies a thin layer of plastic shell made of acrylic thermoplastic enriched with boron. This component absorbs slow-moving neutrons, preventing pre-detonation. The critical components for the fission reaction are encased in a thick layer of aluminum, known as the aluminum pusher, which uniformly transfers shock waves from the explosives to the uranium core. The aluminum sphere is surrounded by 32 blocks of faster explosives, consisting of 61% RDX and 39% TNT. An additional layer of 32 explosive blocks comprised of 70% boron nitrate and 30% of TNT lies outside, forming an explosive lens to shape the detonation wave. Each explosive block contains a detonator for initiation. This assembly is referred to as the physics package, which is encased in a fixed steel case to contain the explosion of fast and slow explosives. Precise and simultaneous detonation of all explosive blocks is critical for a symmetric detonation, ensuring a nuclear chain reaction. Lastly, the X unit, an electric component with capacitors, produces electric current, distributing it simultaneously to all 32 detonators.